My name is Nicholas Espinal. This is my 8th question on my Chapter 24 quiz, and this is what it asks. A 6 microfarad parallel plate capacitor has charges of 40 microcoulombs on its plates. How much potential energy is stored in this capacitor? So we're going to need to know the potential energy stored in the capacitor. We'll need to know the equation for that. The equation for that, the stored potential energy on a capacitor, is 1/2 times the charge in the capacitor multiplied by the voltage on the capacitor. We're also going to need to know the definition of capacitance on a capacitor, which is going to be the charge on it divided by the voltage of the capacitor. And we're going to need to derive V, so we could input it into this potential energy equation and put this equation in terms of Q and C, which are the values that are given to us in the problem, so we could find the potential energy stored. So by switching around V and C, we're going to have the voltage is equal to the charge divided by the capacitance. Then we're going to put this back into the potential energy equation, and we're going to get the potential energy stored is 1/2 Q squared over the capacitance. So we have this equation, and now we need to put our values in. They tell us that the charge is 40 microcoulombs, which is really just 40 times 10 to the negative 6 coulombs. 10 to the negative 6 is micro, that's the prefix. Then the capacitance is 6 microfarads. Same thing, it's going to be 6 times 10 to the negative 6 farads. And we're just going to put this into the equation, and this is the amount of stored energy, stored potential energy on the capacitor. So by calculating this, we're going to find that the stored potential energy is 1.33 times 10 to the negative 4 joules. If we bring the decimal to the right, we'll need to increase this exponent here, or rather decrease to 10 to the negative 6, which is just microjoules. So you're going to have the potential energy stored is 133 microjoules. And we look at what our answer choices is, and that is the right answer, 133 microjoules. And that is how we figured out what the potential energy stored on the capacitor is. Thank you.